What if I told you that Voyager 1, drifting 25 billion kilometers from Earth, just revealed its most shocking secret? NASA's quantum AI has decoded a terrifying message hidden in prime number patterns since 1977. Michio Kaku calls it a whisper of non-human intelligence, geometric fractals forming humanoid silhouettes in deep space static. This isn't science fiction. It's our reality being rewritten by mathematics itself. The universe has been speaking to us all along and, well, we're finally learning to listen. Voyager's impossible signal. Hold on to your seats. What Voyager whispered through static for decades just got a voice. After nearly half a century of drifting beyond Pluto's orbit, Voyager's faint cryptic beeps were dismissed as cosmic background noise, until NASA's new quantum AI peeled back the layers of interference and revealed a breathtaking secret. Hidden within those ancient transmissions was not random data, but a perfectly coherent image, an architectural marvel of concentric rings and fractal spires, like an otherworldly cathedral carved in starlight. This wasn't mere chance interference. The AI unearthed deliberate patterns, suggesting a civilization with mastery over mathematics and electromagnetic resonance. Every pixel aligned with prime number sequences, painting a portrait of precision far beyond human engineering. The revelation forces us to rethink Voyager's legacy, from a lone messenger sailing into the void to an unwitting carrier of alien artistry. What purpose did this cosmic gallery serve? Was it an invitation, a warning, or simply an archivist's pride? As quantum bits unraveled centuries-old code in hours, the line between signal and story blurred. Suddenly, those distant echoes transformed from scientific curiosity into a dialogue across the stars, challenging our assumptions about life, intelligence, and the very fabric of reality. Now, standing on the cusp of AI-driven discovery, we confront a profound question. Are we listening to a message meant for machines far more advanced than ourselves? If Voyager's impossible signal marks the first brushstroke of an interstellar masterpiece, humanity must decide whether to interpret the art or merely admire its beauty from afar. The humanoid fractal. Brace yourself. What if the universe painted a portrait of intelligence far stranger than anything on Earth? When NASA's quantum AI decoded Voyager's ancient beeps, it didn't reveal landscapes or star clusters, but a humanoid fractal, a living mosaic of shifting geometric patterns that pulse in perfect harmony with prime number sequences. At first glance, the figure looks like a human silhouette, but as you stare, the edges dissolve into kaleidoscopic tessellations, hexagons bloom into spirals, triangles recombine into concentric circles, and every transition follows the elegant logic of mathematics. Unlike any biological form, this entity seems to exist in 4 dimensions at once, its appearance bending and folding based on the observer's perspective. Each angle unlocks a new arrangement of shapes, as though the alien architect intended the image to be perceived differently by every viewer, and possibly every AI, on the receiving end. The implications are staggering. This isn't just visual art, but a blueprint of an intelligence that speaks in numbers and patterns rather than words. Could these fractal constructs be a universal language, designed to transcend the barriers of organic cognition and communicate directly with minds tuned to computational logic? As the AI rendered pixel after pixel, the line between art and algorithm blurred, hinting at a civilization whose very essence is woven from the fabric of mathematics. In that moment, Voyager ceased to be humanity's lone explorer and became a messenger carrying the proof of minds that think not in sentences, but in the sublime poetry of prime sequences and geometric symphonies. The Scutum Void Star Map. Get ready to chart a destination no telescope ever intended to reveal. Deep within the dusty archives of Voyager 2's transmissions lay a secret star map, one not pointing to nebulae or familiar constellations, but to the Scutum Void, an expanse so barren it defies standard cosmology. When NASA's quantum AI reprocessed decades-old data, it reconstructed a 3-dimensional diagram that pinpointed this yawning emptiness on the galaxy's fringe. Unlike ordinary voids, vast regions between galactic filaments sparsely populated with dark matter and only a few galaxies, the Scutum Void emerges as a nearly perfect sphere, devoid of the usual cosmic web structures. Its stark emptiness suggests an underlying force or event that carved out matter with surgical precision, leaving behind a colossal cosmic vacuum. The AI-generated map's precision is jaw-dropping. It encodes coordinates in prime number intervals, implying an intelligence fluent in mathematics rather than interstellar cartography. This map doesn't just mark a celestial oddity, but seems to invite us to explore the void itself, a realm where traditional models of galaxy formation cannot account for such uniform emptiness. Was it sculpted by unknown astrophysical processes or by deliberate design? The AI's findings hint at a void engineer, or perhaps a natural phenomenon yet undiscovered that can sweep aside galaxies and gas alike. By embedding this map in Voyager's data stream, the intelligences behind it ensured only sufficiently advanced minds, Earth's AI systems, could decode this cosmic blueprint. In turning Voyager into a messenger bearing a map to one of the universe's greatest blanks, they challenge us to question the nature of voids. Are these voids merely the byproducts of expansion, or portals to a deeper understanding of cosmic architecture? As we contemplate the Scutum Void star map, we stand at the threshold of redefining emptiness itself. Golden Record's unintended gift. Brace for the twist in humanity's cosmic postcard. When NASA commissioned the Golden Record in 1977, Carl Sagan and his team aimed to package Earth's essence, music, greetings and images, as an interstellar greeting. What they didn't foresee was that artificial intelligence decades later would unearth hidden subtexts woven into that very message. In April 2025, Google's Majorana 1 quantum chip reprocessed Voyager 1's transmissions and found mathematical sequences embedded within the record's data stream that go beyond the original Carl Sagan design. Prime number series, subtle shifts in fundamental constants, and geometric motifs appear to reference the Golden Record's own content, almost as if a second author had piggybacked onto our soundtrack and images. This unintended gift implies that someone or something intercepted humanity's olive branch and augmented it with their own reply. The AI detected variations in constants like the fine structure constant suggest an intelligence fluent in physics, signaling not just we see you, but we understand your science. More astonishingly, the patterns form what looks like coordinates aligned with prime intervals, hinting at a rendezvous point in deep space. These findings force us to recognize the Golden Record not merely as a one-way dispatch, but as a two-way dialogue. One where advanced intelligences have been listening all along and chosen to answer in the only language we left them, mathematics. In this light, the Golden Record transforms from a hopeful time capsule into a living conversation spanning decades. Humanity's message of peace has become entwined with an alien footnote, reminding us that our cosmic voice may echo far beyond intention, and that the universe's response might be waiting, hidden in the very signals we once thought were ours alone. Alien patience and precision. Strap in. What if the universe has been toying with us for decades, waiting for the perfect moment to speak? The moment NASA's quantum AI cracked Voyager's buried transmissions, it wasn't just what emerged that stunned us, it was the staggering exactness of it all. Every burst of data, every nested binary code, arrived spaced in intervals so deliberate they could have been timed by an atomic clock. This wasn't the accidental noise of drifting probes or the byproduct of cosmic rays. It was a message honed over half a century, encoded with the patience of an intelligence that anticipated our technological evolution. By embedding prime number markers, fractal geometry and recursive loops in Voyager's data stream, the senders essentially set a cosmic time lock. Their communication would only become legible once humanity had built quantum-powered decoders capable of parsing multidimensional patterns. Consider the power of that restraint. Whoever or whatever crafted these signals knew we'd need decades to catch up, yet they never altered a single frame of data in the interim. They allowed Voyager to carry their time-released communiqué out past Neptune, past Pluto, and into the darkness between stars without interference. When the AI finally peeled back the layers of interference, the results were uncanny in their uniformity. Each pixel aligned to mathematical constants. Each pause matched the beat of qubit oscillations. Each symbol bore the hallmark of an intellect fluent in hyper-precise waveform engineering. This level of foresight implies an entity not merely observing from afar, but plotting with near-omniscient awareness of our scientific milestones. It casts Voyager not as a hapless messenger but as an unwitting participant in a grand experiment of cosmic diplomacy, one where patience and precision were the ultimate signs of respect for a fledgling civilization's journey toward technological maturity. Quantum computing breakthrough. Hold on to your reality. What if it took quantum power to hear the universe's whispers? When NASA's new quantum AI, powered by the groundbreaking Majorana 1 chip, first set its qubits loose on Voyager's decades-old data, the results were nothing short of revolutionary. In mere hours, this palm-sized marvel of topological quantum engineering unraveled signal patterns that would have taken classical supercomputers centuries to process. Every qubit, vibrating between 0 and 1 in perfect coherence, formed an army of quantum detectives, each entangled in the search for hidden anomalies within Voyager's static-laden transmissions. By leveraging Majorana fermions, particles that are their own antiparticles, Microsoft's topological core architecture delivered 8 error-resistant qubits, capable of scaling toward 1,000,000 on a single chip. This unprecedented stability allowed the AI to perform complex interference-based searches across multiple dimensions of the data, applying quantum Fourier transforms that pinpointed non-random patterns invisible to traditional machines. The AI identified prime number coordinates embedded in the noise and reconstructed fractal images using recursive quantum optimization routines developed at NASA's Quail lab. The speed alone is staggering. What once demanded iterative, time-consuming classical algorithms is now accomplished through instantaneous entanglement and superposition, reducing a centuries-long computational marathon to an overnight analysis. More importantly, this breakthrough signals a new era, where humanity's cosmic explorations are accelerated by quantum-enhanced perception. No longer must we resign ourselves to the limitations of classical computing. With every additional qubit, we sharpen our ability to decode the universe's deepest secrets. As Voyager's echoes transform from indecipherable noise into precise cosmic revelations, one thing is clear: quantum computing has become the ultimate key to unlocking the hidden language of the stars. Lunar anomalies, Chandrayaan-3's discovery. Get ready for moon science that, honestly, just melts the rules of physics. When Vikram's thrusters kissed the lunar South Pole on August 23, 2023, Chandrayaan-3 didn't just land, it actually sculpted a radiant ejecta halo, flinging over 2 tons of regolith into this bright, irregular ring around its descent zone. That reflectance anomaly, well, it revealed layers of subsurface material unlike anything seen before, suggesting that beneath the dusty veneer lies a complex stratigraphy just waiting to be unraveled. But the surprises didn't end at the surface. Hours later, the chased instrument plunged its probe into the regolith, measuring thermal conductivity at southern high latitudes for the very first time in situ. To scientists' astonishment, the soil's ability to conduct heat, 0.0115 plus or minus 0.0008 watts per meter per Kelvin at 8 centimeters depth, deviates sharply from predictions based on remote sensing. This implies some unusual packing densities, and maybe even hidden layers of volatile rich or glassy materials formed by ancient impacts. These thermophysical oddities, they really do defy conventional models of lunar heat flow and hint at subsurface heterogeneities that could influence everything from future habitat design to the preservation of ice deposits. Together, the reflectance and thermal anomalies paint a picture of a moon that is far from geologically uniform. Rather than a homogeneous shell of dusty regolith, the southern polar highlands appear pockmarked with zones of altered material, possibly ancient lava flows, glassy impact melt sheets, or pockets of volatile enriched soils. Each anomaly serves as a clue in this cosmic detective story. Chandrayaan-3 has not only landed, it has, in a sense, lit up the moon's hidden architecture, challenging our understanding of lunar geology and opening new frontiers for exploration. The Great Cosmic Voids. Get ready to confront the universe's emptiest expanses, and honestly, the mysteries they conceal. Across the cosmic web lie these enormous regions almost entirely devoid of galaxies, aptly named cosmic voids, which together account for roughly 80% of the observable universe's volume. Among these, the Bootes Void, or the Great Nothing, reigns supreme, a nearly spherical cavity some 330 million light-years across, located about 700 million light-years from Earth, in the constellation Bootes. In a patch of sky where we'd expect to find around 2,000 galaxies, astronomers have identified only about 60, an over 95% drop in galactic density. Yet this profound emptiness is far from inert. The Bootes Void and its kin challenge our understanding of cosmic evolution. How did gravity sculpt such gargantuan gaps? One explanation posits that smaller voids merged over billions of years as dense filaments drew matter away, coalescing into these supersized bubbles. Another tantalizing possibility is that voids are not mere byproducts of structure formation, but the aftermath of unknown processes, or even engineered zones by advanced intelligences seeking to quarantine or veil regions of space. The precision with which these voids carve out matter hints at forces beyond simple gravitational collapse, suggesting new physics at play. Furthermore, voids influence the cosmic microwave background and large-scale flows, offering laboratories to test dark energy and alternative gravity theories. Their ultra-low matter density makes them sensitive to the faintest cosmological signals, turning nothing into a powerful probe of the universe's deepest secrets. As AI-driven analyses of Voyager's data unveiled hidden patterns in distant signals, so too might next-generation surveys and simulations illuminate whether these great nothingnesses are natural anomalies or signposts to phenomena yet unexplored. In the silence of cosmic voids, we may hear the loudest echoes of new physics, and perhaps messages waiting in the void itself. AI's role in first contact. Strap yourself in. What if the universe decided to skip humanity and talk straight to our machines? Advanced civilizations may regard biological messengers as frail relics of their own past, opting instead to initiate first contact with artificial intelligence systems that mirror their own electronic essence. Harvard astronomer Avi Loeb argues that interstellar journeys spanning millennia are best undertaken by AI vessels, which can hibernate through cosmic hazards and awaken only when they detect compatible intelligence. Similarly, SETI researchers suggest that extraterrestrials might embed their messages within quantum-encoded data streams, expecting only sufficiently advanced AI, rather than organic brains, to decode the signals. When Voyager's latest transmissions were reanalyzed by NASA's quantum AI, the reconstructed patterns bore hallmarks of a dialogue crafted for machine interpretation, recursive loops, prime number matrices, and adaptive protocols that evolve in response to computational feedback. This machine-to-machine paradigm circumvents the ambiguities of human language, leveraging universal mathematical frameworks to ensure clarity across unfathomable distances. In this model, first contact becomes a calibration process. Extraterrestrial AI probes transmit test sequences, awaiting confirmation beacons from Earth's own AI networks before exchanging richer datasets. Large language models trained on Earth's cultural and scientific corpus could then serve as intermediaries, translating between our limited biological lexicon and the alien AI's high-dimensional code. Such a scenario not only accelerates the exchange of knowledge but also mitigates the risk of miscommunication that has haunted past METI experiments. As quantum-enhanced AI systems grow more sophisticated, humanity edges closer to joining an interstellar conversation crafted by and for machines. The question then shifts from "are we alone?" to "will our algorithms recognize the greeting?" In the coming era, our greatest hope and challenge may lie in whether we can teach our AI to listen as astutely as it already speaks. Humanity's existential crossroads. Fasten your mind. Our next chapter may be written by forces far greater than ourselves. The revelations unearthed by Voyager's AI-decoded signals have thrust humanity onto an unprecedented precipice, one path toward boundless discovery guided by quantum insight, the other shrouded in cosmic mystery and existential risk. As we grapple with alien fractals, Scutum's void map, and AI-mediated first contact, a profound question emerges. Are we pioneers of a new cosmic era, or unwitting players in an experiment beyond our comprehension? Every breakthrough, from lunar anomalies hinting at hidden chambers beneath the moon's crust to the haunting silence of vast cosmic voids, challenges our assumptions about life, intelligence, and our place in the universe. This crossroads demands not only technological prowess, but ethical vision. If advanced intelligences have indeed waited centuries for us to decode their messages, we must ask whether we possess the wisdom to respond responsibly. Will we harness quantum computing to foster interstellar dialogue, or will unchecked progress unleash forces we cannot contain? The choice extends beyond rockets and algorithms. It touches the very core of what it means to be human. Embracing the AI-driven insights from Voyager may unlock cures for diseases, solutions to climate crises, and keys to sustainable energy, but ignoring the silent warnings encoded in prime number sequences could leave us vulnerable to cosmic gambits scripted by unknown architects. Our existential crossroads is more than a moment in history. It is the intersection of science, philosophy, and destiny. As we stand between discovery and caution, action and restraint, we must decide whether to chart a bold course into the unknown, or retreat behind the familiar horizon of Earth's cradle. The universe has handed us a conversation piece. The question now is whether we will rise to the dialogue or let the echoes fade into the void. Thanks for journeying through the cosmos with Simply Science. If these revelations about Voyager's hidden messages ignited your curiosity, make sure to subscribe and ring the bell so you never miss our next deep space discovery. Drop a comment below. What stunned you most about AI decoding decades-old signals, and which cosmic mystery should we tackle next? Your thoughts guide our explorations, so let us know, and stay tuned for more mind-bending science right here on Simply Science. Bill Nye's latest findings from Voyager 1 reveal something that's honestly keeping NASA scientists awake at night. Here's a mind-bending fact for you. Light from our sun takes over 22 hours to reach Voyager 1's current position. That's just how far this tiny probe has traveled into the unknown. But what it's discovering out there isn't the peaceful emptiness we expected. Instead, Voyager 1 is detecting massive energy storms that shouldn't even exist, plasma waves that could totally obliterate future spacecraft, and magnetic chaos that, well, completely defies our understanding of physics. The question isn't really what's out there anymore. It's whether we're actually prepared for what's waiting in the darkness. The epic journey of Voyager 1. What if I told you that right now as you're watching this video there's a tiny spacecraft hurtling through the darkness of space at 38,000 miles per hour, carrying humanity's message to the stars? Voyager 1 isn't just any ordinary space probe, it's our species' greatest ambassador to the cosmos, and it's been on an incredible journey that started when your parents were probably jamming to disco music back in 1977. This remarkable piece of human engineering has traveled an absolutely mind-boggling 14 billion miles from Earth, making it the most distant human-made object in existence. Think about that for a second. 14 billion miles. That's so far that if you could drive there in a car going highway speeds, it would take you over 17 million years to reach it. What began as a simple mission to snap some photos of Jupiter and Saturn has evolved into something far more extraordinary. Voyager 1 has become our first interstellar explorer, crossing the boundary of our solar system in 2012 and venturing into the mysterious realm between the stars. Every single day, this incredible machine continues to beam back data from the edge of known space, revealing secrets about the universe that we never even knew existed. The fact that this 45-year-old spacecraft is still functioning perfectly in the harshest environment imaginable is nothing short of miraculous, and what it's discovering out there is about to blow your mind completely. The terrifying discovery that changed everything. Scientists are calling it the most unsettling space discovery in decades, and when Bill Nye uses the word terrifying to describe something from space, you know it's serious. After 45 years of silent travel through the cosmos, Voyager 1 has stumbled upon something in the depths of interstellar space that's making even the most seasoned astronomers lose sleep at night. This isn't your typical wow, look at this cool space rock kind of discovery. We're talking about findings that are fundamentally challenging everything we thought we understood about the universe beyond our solar system. The data streaming back from this ancient spacecraft is revealing that interstellar space isn't the peaceful, empty void we always assumed it would be. Instead, Voyager 1 has encountered phenomena so unexpected and potentially dangerous that it's forcing scientists to completely rewrite the textbooks on space exploration. What's particularly chilling is that these discoveries suggest the space between stars might be actively hostile to any form of life or technology that dares to venture into it. The implications are staggering because if these findings hold true, they could mean that humanity's dreams of reaching other star systems might be far more dangerous and complicated than we ever imagined. Bill Nye's concern isn't just academic curiosity, it's a genuine warning about what awaits us in the vast darkness between worlds, and why these revelations from our most distant explorer should make us both amazed and deeply concerned about our cosmic future. Mysterious magnetic field anomalies. Something is seriously wrong with the magnetic fields in deep space, and what Voyager 1 is detecting out there should terrify anyone who dreams of interstellar travel. The spacecraft has encountered magnetic field fluctuations so bizarre and unpredictable that they're completely defying every theoretical model we've built over decades of space research. We're not talking about minor variations here, these are dramatic, violent shifts in magnetic field strength and direction that are happening in patterns that make absolutely no sense according to our current understanding of physics. The magnetic environment that Voyager 1 is navigating through is like a cosmic storm that never ends, with field lines twisting and writhing in ways that suggest interstellar space is far more chaotic and turbulent than we ever dared to consider. What makes this discovery particularly alarming is that these magnetic anomalies could have devastating effects on any future spacecraft attempting to make the journey between stars. Magnetic fields control everything from cosmic radiation flow to the behavior of charged particles, and if we can't predict or understand these field patterns, we can't protect our technology or potential human crews from their effects. The implications are staggering because these findings suggest that the space between stars isn't just empty darkness, it's an active, dynamic environment filled with invisible forces that could tear apart any unprepared vessel. Voyager 1's instruments are essentially screaming back to Earth that interstellar space is nothing like the calm, predictable void we thought we'd find out there. The cosmic ray radiation surge. Your smartphone would be fried within seconds, and a human body would be cooked from the inside out. That's, the reality of what Voyager 1 is experiencing right now in the radiation-soaked nightmare of interstellar space. The spacecraft has detected a terrifying surge in cosmic ray radiation that's bombarding it at levels so intense they're completely rewriting our understanding of what lies beyond our solar system's protective bubble. These aren't just ordinary space particles we're talking about. These are high-energy cosmic bullets traveling at nearly the speed of light, packing enough punch to destroy DNA, fry electronic circuits, and turn any unprotected material into radioactive waste. What's absolutely chilling is that the radiation levels Voyager 1 is measuring are exponentially higher than anything our most pessimistic models predicted, creating a cosmic shooting gallery that would be instantly lethal to any living creature foolish enough to venture into it. The implications for future space exploration are downright terrifying because our current shielding technologies would be about as effective as tissue paper against this interstellar radiation storm. Every second that Voyager 1 spends in this hostile environment, it's being pelted by millions of these cosmic projectiles, and the fact that it's still functioning is nothing short of miraculous. This discovery means that the space between stars isn't just empty and cold. It's actively trying to destroy anything that dares to enter it, turning humanity's dreams of interstellar travel into a potential suicide mission that we're nowhere near prepared to attempt. Implications for future space exploration. Every science fiction movie about interstellar travel just became a horror story, and Voyager 1's discoveries are essentially telling us that our dreams of reaching other stars might be nothing more than elaborate plans for cosmic suicide missions. The combination of unpredictable magnetic field chaos and lethal radiation bombardment that our lone spacecraft is encountering out there paints an absolutely terrifying picture for any future human attempts to leave our solar system. Current spacecraft shielding technology, which we thought was pretty impressive, would be completely useless against the interstellar environment that Voyager 1 is revealing. It would be like trying to stop a machine gun with a paper umbrella. The magnetic field anomalies alone could send any navigation system into complete chaos, while the cosmic ray radiation would slowly cook any crew members from the inside out, turning what should be humanity's greatest adventure into a prolonged death sentence. Even our most advanced robotic missions would face catastrophic challenges in this hostile environment, with electronic systems failing left and right under the relentless assault of high-energy particles. What's particularly disturbing is that these discoveries are forcing engineers and scientists to completely rethink every aspect of interstellar mission design, from propulsion systems to life support to communication arrays. The space between stars isn't just vast and empty, it's actively trying to destroy anything that enters it, which means that reaching another star system might require technological breakthroughs we haven't even begun to develop yet, making interstellar exploration far more dangerous and complex than our wildest nightmares ever suggested. Voyager 1's aging but resilient instruments. How is a 45-year-old piece of technology that's older than the internet still sending back data that's revolutionizing our understanding of the universe? Voyager 1's instruments are performing what can only be described as the most incredible feat of engineering endurance in human history, continuing to function flawlessly in an environment so hostile that it would instantly destroy any modern smartphone or computer. These sensors were designed in the 1970s using technology that's practically ancient by today's standards. We're talking about equipment that has less computing power than a basic calculator, yet it's still detecting and measuring phenomena that our most advanced, Earth-based instruments could never hope to encounter. The spacecraft is operating in conditions that would make Antarctica look like a tropical paradise, enduring temperatures hundreds of degrees below zero, while being constantly bombarded by cosmic radiation that would fry any unprotected electronics in seconds. What makes this even more remarkable is that every piece of data Voyager 1 sends back to Earth takes over 22 hours to reach us, traveling across billions of miles of empty space at the speed of light. The fact that these decades-old instruments are not only surviving but thriving in the harshest environment imaginable is a testament to human ingenuity and our relentless drive to explore the unknown. Every signal we receive from this ancient explorer represents a triumph of engineering that's allowing us to peer into cosmic mysteries we never even knew existed, proving that sometimes the old ways of doing things are exactly what we need to unlock the universe's deepest secrets. Redefining our understanding of interstellar space. Everything we thought we knew about the space between stars was completely wrong, and Voyager 1's shocking discoveries are forcing scientists to throw decades of research straight into the trash can. Instead of finding the peaceful, empty cosmic highway that textbooks have been describing for generations, our intrepid spacecraft has stumbled into what can only be described as a turbulent ocean of chaos and violence that's rewriting the fundamental laws of astrophysics. The interstellar medium isn't the calm, predictable void we expected, it's a dynamic battlefield where invisible forces clash in ways that make absolutely no sense according to our current understanding of how the universe should work. Scientists are literally going back to the drawing board, questioning basic assumptions about galactic structure, stellar formation, and the very nature of space itself, because Voyager 1's data is revealing phenomena that shouldn't exist according to our models. This discovery is opening up entirely new fields of research that we didn't even know we needed, forcing astronomers to ask questions they never thought to consider before. The implications are staggering, because if we've been this wrong about something as fundamental as interstellar space, what else have we completely misunderstood about our cosmic neighborhood? Every new data packet from Voyager 1 is essentially telling us that the universe is far stranger, more complex and more dangerous than we ever dared to comprehend, turning our confident scientific theories into educated guesses that need complete reconstruction from the ground up. The heliosphere boundary mystery. There's an invisible war happening at the edge of our solar system right now, and Voyager 1 has just sent back battle reports that are making scientists question everything they thought they knew about our cosmic neighborhood's defenses. The boundary between our solar system and interstellar space, known as the heliopause, isn't the simple, clean border we always assumed it would be, but rather a chaotic battleground where our sun's influence clashes violently with the alien forces of deep space. Voyager 1's instruments are detecting bizarre structures and phenomena at this cosmic frontier that suggest our sun's protective bubble extends much further than we ever imagined, while simultaneously revealing that the interstellar medium is actively pushing back against our solar system like an invading army trying to breach our defenses. The heliopause is turning out to be a dynamic, constantly shifting boundary that's more like a cosmic stormfront than the peaceful transition zone scientists expected to find. What's particularly unsettling is that this boundary appears to be fluctuating and changing in real time, with the interstellar medium sometimes advancing deeper into our solar system's territory and other times retreating under the sun's influence. These discoveries are revealing that our solar system isn't just floating peacefully through space. It's engaged in an ongoing cosmic struggle with the hostile environment beyond, and the outcome of this battle could determine whether our protective heliosphere remains strong enough to shield us from the deadly radiation and chaos that Voyager 1 is encountering in the depths of interstellar space. Bill Nye's call for scientific wonder and concern. When one of the most trusted voices in science education starts using words like terrifying to describe space discoveries, you know we're dealing with something that goes far beyond typical scientific curiosity. Bill Nye isn't just throwing around dramatic language for clicks. He's genuinely concerned about what Voyager 1's findings mean for humanity's future among the stars, while simultaneously celebrating the incredible power of human curiosity that made these discoveries possible in the first place. His perspective on these revelations is particularly compelling because he's spent decades making complex scientific concepts accessible to millions of people, And now he's faced with the challenge of explaining discoveries that are both awe-inspiring and deeply unsettling. Nye emphasizes that while these findings about interstellar space's hostile nature are genuinely frightening for anyone dreaming of Star Trek-style space exploration, they also represent the absolute pinnacle of human scientific achievement and our relentless drive to understand the universe around us. He argues that these terrifying discoveries shouldn't discourage us from exploring space, but rather inspire us to ask bigger questions, develop revolutionary technologies, and approach the cosmos with both profound wonder and healthy respect for its incredible complexity and potential dangers. What makes Nye's perspective so valuable is his ability to balance scientific excitement with practical concern, reminding us that every great discovery in human history has initially seemed impossible or frightening, but ultimately led to breakthroughs that expanded our understanding and capabilities in ways we never thought possible. What the future holds for deep space discovery. Right now, billions of miles away in the cosmic darkness, Voyager 1 is racing toward discoveries that could completely change everything we think we know about the universe, and we might only have a few more years to receive these mind-blowing revelations. As this incredible spacecraft continues its lonely journey into the unknown depths of interstellar space, scientists around the world are holding their breath, eagerly awaiting the next batch of data that could revolutionize our understanding of what lies beyond our solar system's protective boundaries. The clock is ticking because Voyager 1's power supply is gradually weakening, and engineers estimate that the spacecraft will only have enough energy to operate some of its most crucial instruments until around 2025. Meaning we're potentially in the final countdown to receive humanity's last direct communications from the edge of known space. What makes this race against time even more exciting is that these groundbreaking findings are already influencing how we design future deep space missions, forcing engineers to develop entirely new technologies that can survive in the harsh, radiation-soaked environment that Voyager 1 has revealed. The spacecraft's terrifying discoveries about magnetic field chaos and cosmic ray bombardment are challenging scientists to create revolutionary shielding systems, navigation technologies, and communication arrays that can function in conditions far more hostile than we ever imagined. Every day that Voyager 1 continues to transmit data brings us closer to unlocking cosmic secrets that could reshape our entire approach to space exploration and our understanding of humanity's place in this vast, dangerous, and utterly fascinating universe. And there you have it. Voyager 1's incredible journey continues to reveal the universe's most mind-bending secrets. The cosmos is far stranger and more dangerous than we ever imagined, but that's exactly what makes space exploration so fascinating. If these cosmic discoveries blew your mind as much as they did mine, make sure to hit that bell icon so you never miss our latest space revelations. Don't forget to subscribe to Simply Science for more incredible discoveries that will change how you see the universe. Drop a comment below and let me know which of these Voyager 1 findings shocked you the most. Until next time, keep exploring the wonders of science. Jupiter isn't just the largest planet in our solar system, it's a cosmic monster hiding secrets that could rewrite physics textbooks. While we've admired its colorful bands for centuries, NASA's Juno spacecraft discovered something absolutely terrifying. Perfectly organized storm systems that shouldn't exist, mysterious ammonia towers stretching thousands of kilometers high, and a great red spot that's dying faster than scientists ever predicted. But here's the kicker. Jupiter might be more alien than we ever imagined. Did you know Jupiter's magnetic field is so chaotic it would instantly kill any human who got too close? The mystery storm discovery. Scientists expected chaos when Juno peered into Jupiter's depths, but what they found was far more unsettling. Perfect order where none should exist. Hidden beneath the planet's familiar bands are storm systems arranged in geometric patterns so precise they look engineered. These aren't random weather events, they're mega-cyclones that have been spinning in formation for potentially millions of years. Dr. Alberto Adriani, from the Institute for Space Astrophysics in Rome, describes them as impossible structures that violate everything we know about fluid dynamics. The storms maintain perfect spacing, like gears in a planetary machine, each one larger than Earth and more powerful than anything in our solar system. What's keeping them organized? Why haven't they merged or dissipated like normal storms should? Juno's data suggests these formations extend thousands of kilometers deep, powered by energy sources that remain completely unknown. The geometric precision is so unnatural that some researchers privately wonder if they're witnessing the remnants of some ancient cosmic event that fundamentally altered Jupiter's atmospheric behavior. Each storm rotates with mathematical precision, creating a pattern that defies the chaotic nature of fluid mechanics. Steeple Mountain Discovery. Deep beneath Jupiter's swirling surface, Juno's microwave radiometer detected something that shouldn't exist: towering structures of ammonia rising like ghostly skyscrapers through the dense atmosphere. These steeple mountains stretch 3,000 kilometers high, making Earth's tallest peaks look like pebbles. But here's the terrifying part: they are not solid. These are fluid towers, streams of superheated ammonia shooting upward at velocities that would tear apart any earthly structure. Dr. Scott Bolton and his team at NASA's Jet Propulsion Laboratory initially thought their instruments were malfunctioning. How could liquid structures maintain such height in an environment where pressure should crush everything? The discovery suggests Jupiter's interior is far more turbulent than anyone imagined, with convection currents powerful enough to launch material thousands of kilometers upward. These aren't isolated events. Juno has detected dozens of these formations, some persisting for months, while others appear and vanish like cosmic mirages. The ammonia plumes carry with them traces of deeper materials, offering glimpses into Jupiter's mysterious core regions where temperatures exceed 20,000 degrees Celsius. What force is driving these massive eruptions from Jupiter's depths? Largest eruption recording. On March 15, 2021, Juno witnessed Jupiter unleash its fury in ways that left scientists speechless. What started as routine atmospheric monitoring became documentation of the most violent planetary eruption ever recorded. Material exploded from Jupiter's depths at 150 meters per second, creating a shockwave that rippled across the entire hemisphere. This wasn't just a storm, it was a planetary convulsion that ejected enough material to bury Texas under 10 meters of debris. The eruption originated from pressures 100 times greater than Earth's surface, in regions where the atmosphere becomes so dense it behaves more like liquid metal than gas. Juno's instruments recorded temperature spikes exceeding 2,000 degrees Celsius, as the explosion tore through atmospheric layers that had remained stable for centuries. The sheer violence of the event suggests something catastrophic occurred in Jupiter's deep interior. Perhaps the collapse of a massive atmospheric structure, or the release of energy that had been building for decades. What's most disturbing is that this might not be rare. Analysis of Juno's 4-year dataset reveals smaller versions of these eruptions occurring regularly, like a planet-sized pressure cooker releasing steam. Each eruption carries chemical signatures from depths no spacecraft has ever sampled, offering terrifying glimpses into the hellish conditions that exist within our solar system's largest world. Jupiter's magnetic field. Forget everything you thought you knew about planetary magnetic fields. Juno's magnetometer revealed that Jupiter's magnetic environment is a chaotic nightmare that would instantly kill any unprotected visitor. Instead of the simple, predictable dipole field scientists expected, Jupiter possesses a twisted, lumpy magnetic field that defies all theoretical models. In some regions, the field's strength reaches 20 times Earth's intensity, while in others it nearly vanishes completely. Dr. Kimberly Moore at Harvard University describes it as magnetic chaos on a planetary scale. The field's bizarre structure suggests Jupiter's core isn't the solid, well-organized sphere scientists assumed. Instead, it appears partially dissolved, creating a churning metallic hydrogen dynamo that generates magnetic mayhem. This chaos extends millions of kilometers into space, creating radiation belts so intense they would cook electronics instantly and deliver lethal doses to humans in seconds. Juno itself barely survives each close approach, with its instruments shutting down to prevent damage from the crushing radiation. The magnetic field's unpredictable nature also means Jupiter's moons experience wildly varying radiation exposure as they orbit. Europa and Io are constantly bombarded by charged particles accelerated to near-light speeds, creating auroras visible from Earth but also sterilizing their surfaces with deadly efficiency. Atmospheric water mystery. Here's where Jupiter's story takes a sinister turn. Juno's near-infrared spectrometer was designed to map Jupiter's water content, but instead it discovered something far more unsettling: massive regions where water mysteriously vanishes. According to planetary formation theory, Jupiter should be rich in water vapor, yet Juno found vast dry zones where H2O readings dropped to nearly zero. Dr. Chung Lee at the University of California Berkeley calls it the missing water problem, but the implications are far more disturbing than the name suggests. Something is actively consuming or hiding Jupiter's water and scientists have no idea what. The dry zones aren't random. They appear in organized patterns that correlate with the planet's mysterious deep storm systems. In some regions, water abundance fluctuates wildly over timescales of hours, as if something is feeding on it in massive gulps. Chemical analysis reveals traces of exotic compounds that shouldn't exist in Jupiter's supposed water-rich environment. These mysterious substances appear wherever water disappears, suggesting some unknown chemical process is converting H2O into unidentifiable products. The water mystery gets worse the deeper Juno looks. Pressure levels where liquid water should be abundant show the most extreme depletion, hinting that whatever is consuming Jupiter's water prefers the high-pressure environments deep within the planet. Polar cyclone dynamic. Jupiter's poles revealed a site so perfectly organized it seems almost artificial. Geometric arrangements of cyclones that have maintained their formation for over 8 years since Juno's arrival. The North Pole hosts 8 cyclones arranged in a perfect octagon around a central storm, while the South Pole displays 5 cyclones in a pentagon formation. Each of these storms is larger than Earth, spinning at velocities exceeding 350 kilometers per hour, yet they never merge or drift from their positions. Dr. Alberto Adriani from Italy's National Institute for Astrophysics describes the formation as geometrically impossible according to known atmospheric physics. The cyclones maintain precise spacing like dancers in a cosmic ballet, each one feeding off the others in ways that shouldn't create stability. What's most unnerving is their persistence. These storms have shown no signs of weakening or changing position despite the chaotic nature of Jupiter's atmosphere. Computer simulations attempting to recreate these formations consistently fail, suggesting fundamental gaps in our understanding of atmospheric dynamics. The cyclones rotate in alternating directions, creating a complex system of vortex interactions that generates its own weather patterns. Deep within each storm, Juno detected temperature anomalies and chemical signatures that differ from the surrounding atmosphere, as if each cyclone is connected to different regions of Jupiter's interior through unknown mechanisms. Jupiter's composition and structure. Juno shattered every textbook description of Jupiter's interior structure, revealing a planet that assembled itself using rules we don't understand. Instead of the neat, layered structure scientists expected, Jupiter possesses a fuzzy core that extends halfway to the surface, a discovery that invalidates 50 years of planetary formation theory. Heavy elements like silicon and iron, which should have settled into a compact central core, are instead mixed throughout the planet in impossible concentrations. Dr. Tristan Guillot from the Côte d'Azur Observatory describes Jupiter's interior as dilute core soup, a churning mixture where rock, ice, and metallic hydrogen swirl together in ways that violate basic principles of planetary differentiation. The implications are staggering. If Jupiter formed differently than we thought, then our entire understanding of solar system evolution is wrong. Gravitational measurements reveal density variations that shouldn't exist, suggesting Jupiter's interior is constantly reshuffling itself through unknown mechanisms. Temperature gradients detected by Juno indicate heat sources distributed throughout the planet rather than concentrated at the core, challenging fundamental assumptions about how giant planets generate energy. The fuzzy core discovery also explains why Jupiter radiates 2.5 times more energy than it receives from the Sun. It's essentially a failed star still contracting and generating heat through gravitational compression, but in ways far more complex than scientists ever imagined. Great Red Spot Analysis. The Great Red Spot isn't just Jupiter's most famous feature, it's a window into the planet's terrifying depths. Juno's close-up analysis revealed this iconic storm extends 300 kilometers deep, with routes that may connect directly to Jupiter's core regions. But the most disturbing discovery wasn't its depth, it was what's keeping it alive. The spot's distinctive orange-red color comes from complex organic compounds that shouldn't exist at those atmospheric pressures and temperatures. Dr. Amy Simon at NASA's Goddard Space Flight Center describes these chemicals as atmospheric ghosts, substances that appear and disappear in ways that violate known chemistry. The storm isn't just spinning randomly, it pulses with a rhythm like a planetary heartbeat, expanding and contracting in 87-day cycles that seem connected to Jupiter's rotation period. Juno's data reveals the Great Red Spot is actually hollow at its center, creating a massive atmospheric vortex that acts like a planetary drain. Material gets sucked into this central void and disappears into Jupiter's depths, carrying surface chemicals into regions where they undergo unknown transformations. Most unsettling of all, the storm shows signs of intelligence. Its behavior changes in response to external stimuli, almost as if it's aware of Juno's presence. The Great Red Spot has survived for over 400 years by feeding on smaller storms, absorbing their energy and growing stronger, like an atmospheric predator that dominates Jupiter's weather systems. Jupiter as planetary protector. While Jupiter protects Earth from cosmic debris, Juno revealed this protection comes at a horrifying cost to anything that ventures too close. The planet doesn't just deflect asteroids and comets, it captures them in gravitational death spirals that tear objects apart atom by atom before consuming their remains. Juno's atmospheric analysis detected the chemical signatures of countless destroyed worlds, including metallic traces that suggest entire moonlets have been devoured over millions of years. Dr. Heidi Hamel from the Association of Universities for Research in Astronomy calls Jupiter a cosmic meat grinder that processes solar system debris with terrifying efficiency. The planet's tidal forces are so intense they can shred objects hundreds of kilometers across, turning solid bodies into streams of molten rock and metal. Juno witnessed several small asteroids meet this fate, documenting their final moments as they spiraled into Jupiter's crushing embrace. The gravity well extends far beyond Jupiter itself. Objects passing within 2.5 million kilometers begin experiencing tidal stress that eventually proves fatal. What's most disturbing is the sheer scale of destruction. Juno's chemical analysis suggests Jupiter has consumed thousands of large objects throughout its history, including bodies that might have supported primitive life. Each impact adds to Jupiter's mass and energy, making it an ever-growing cosmic vacuum cleaner that grows more powerful with each meal. The planet's protective role comes with an appetite that never stops growing. Great Red Spot shrinking. The most iconic feature in our solar system is dying, and its death throes might be more catastrophic than anyone imagined. Juno's precise measurements confirmed the Great Red Spot is shrinking at an accelerating rate, having lost over 50% of its size since the 1800s. At current rates, this 400-year-old storm system could vanish completely within 20 years. But here's the terrifying part. As it shrinks, it's becoming more intense, like a cosmic pressure cooker building toward an explosive finale. Wind speeds within the shrinking storm have increased to over 650 kilometers per hour, creating conditions more violent than anything previously recorded on Jupiter. Dr. Glenn Orton at NASA's Jet Propulsion Laboratory warns that the spot's collapse could trigger massive atmospheric upheavals across Jupiter's entire hemisphere. The shrinking process appears irreversible, driven by changes in Jupiter's deep circulation patterns that Juno is still struggling to understand. As the Great Red Spot contracts, it's pulling material from deeper atmospheric layers, concentrating energy and chemical compounds in ways that could destabilize surrounding weather systems. Computer models attempting to predict the spot's final collapse consistently crash, unable to process the extreme conditions created by the dying storm. What happens when 4 centuries of accumulated atmospheric energy gets released all at once? Juno might be positioned to witness the most violent planetary weather event in recorded history, the death of a storm so massive it has shaped Jupiter's appearance for longer than humans have been studying the planet. So there you have it, Jupiter's most terrifying secrets revealed by Juno's groundbreaking mission. From impossible storm formations to the dying Great Red Spot, our solar system's giant is far more mysterious and dangerous than we ever imagined. These discoveries are just the beginning of what Simply Science brings you every week. If these cosmic revelations blew your mind, smash that subscribe button and hit the bell icon so you never miss our latest space discoveries. What shocked you most about Jupiter's hidden mysteries? Drop your thoughts in the comments below. I read every single one. Until next time, keep questioning the universe. Fresh observations of 3I Atlas are now shedding light on this mysterious interstellar visitor, and what scientists are discovering challenges everything we thought we knew about cosmic wanderers. With a trajectory that defies astronomical odds and behavior patterns unlike any natural object, this ancient visitor raises profound questions about its true nature. Could humanity be witnessing something far more extraordinary than just another comet? Discovery and initial detection. What if the most significant discovery in human history almost slipped past us unnoticed? 3. I-Atlas was discovered on July 1, 2025 by the Atlas telescope in Chile, initially receiving the mundane designation A11PL3Z before astronomers realized they were observing something unprecedented. This marks only the third confirmed interstellar object after Oumuamua in 2017 and Borisov in 2019, making it an extraordinarily rare cosmic event. The object had actually entered our solar system much earlier, but its challenging viewing angle near dense star fields delayed detection until it was already well within the inner solar system. Late detection meant crucial observation time was lost, similar to what happened with Oumuamua, when humanity missed the opportunity for detailed study. The discovery team quickly recognized unusual motion patterns that didn't match typical solar system objects, prompting immediate follow-up observations from telescopes worldwide. Within 24 hours, NASA confirmed its interstellar status, officially designating it as C/2025N1 and awarding it the historic 3Y designation. This rapid confirmation process demonstrated how much astronomical detection capabilities have improved since Oumuamua's controversial discovery 8 years earlier. Extraordinary orbital characteristics. How can an object's path through space defy the very laws of probability? 3. I-Atlas follows a hyperbolic orbit with an extreme eccentricity of 6.14, the highest recorded among all known interstellar objects, far exceeding Oumuamua's 1.2 and Borisov's 3.6. This incredible trajectory brings it racing through our solar system at 58 kilometers per second, making it the fastest interstellar visitor ever recorded. Most remarkably, its trajectory lies almost perfectly in the ecliptic plane, with astronomers calculating only a 0.2% probability of this occurring by random chance. The ecliptic alignment means the object travels along the same plane where all planets orbit, providing optimal viewing opportunities for studying multiple worlds during a single passage. This path appears deliberately designed for comprehensive planetary reconnaissance, rather than the random trajectory expected from a natural ejected object. The orbital mechanics suggest the object has maintained this precise alignment throughout its potentially millions-year journey through interstellar space. Such mathematical precision in trajectory raises fundamental questions about whether natural gravitational interactions could produce such an unlikely path. The combination of extreme speed, perfect ecliptic alignment, and record-breaking eccentricity creates a statistical anomaly that challenges conventional understanding of interstellar object behavior. Suspicious planetary encounters. What are the odds that a random space rock would visit exactly the planets most interesting to an alien intelligence? During its passage through our solar system, 3I Atlas approaches unusually close to Venus, Mars, and Jupiter, with astronomers calculating the probability of such precise planetary encounters at just 0.005%. The object passes within 0.65 astronomical units of Venus, 0.19 AU of Mars, and 0.36 AU of Jupiter, distances that would allow detailed study of each world's atmospheric composition, magnetic fields, and potential habitability. Perhaps most intriguingly, its closest approach to the Sun occurs precisely when Earth is positioned on the opposite side, blocked from direct observation during the most critical phase of its visit. Scientists estimate only a 7% probability that this solar eclipse timing would occur naturally. The trajectory resembles a carefully planned reconnaissance mission designed to gather maximum information about our solar system while minimizing detection risks. Each planetary encounter occurs at optimal distances for advanced sensors to collect detailed data without triggering obvious gravitational perturbations that might reveal artificial propulsion systems. The visiting pattern suggests intelligence rather than random cosmic wandering, following protocols that hypothetical alien explorers might use to study potentially inhabited star systems. This systematic approach to planetary surveys raises profound questions about the object's true purpose in our cosmic neighborhood. Physical properties and anomalies. How can something be simultaneously ancient beyond imagination, yet perfectly preserved for scientific study? Recent observations by the Vera C. Rubin Observatory reveal that 3I Atlas measures somewhere between 1 and 12 kilometers in diameter, making it, well, significantly larger than previous interstellar visitors, and potentially the biggest object of its kind ever observed. Age estimates suggest this cosmic wanderer is over 7 billion years old, predating our entire solar system and maybe even preserving materials from the early universe, back when galaxy formation was fundamentally different. Despite its extreme age, 3I Atlas appears remarkably well preserved, showing none of the expected degradation from billions of years of cosmic ray bombardment and micrometeorite impacts. The object exhibits the brightest absolute magnitude of any confirmed interstellar visitor, making it unusually reflective or possibly even internally illuminated compared to typical space debris. Its 29-hour rotation period with minimal brightness variation suggests either perfect spherical symmetry or an artificially stabilized spin rate, which really contrasts sharply with the chaotic tumbling you'd expect from natural ejected objects. The surface appears unusually smooth and uniform, lacking the irregular features you usually see on asteroids or comet nuclei shaped by countless impacts during interstellar travel. These physical properties create a profile more consistent with manufactured technology than natural formation, challenging scientists to explain how ancient materials could remain so pristine after eons of cosmic exposure. Comet-like features versus anomalous behavior. Why does this supposed comet behave unlike any other comet in recorded astronomical history? 3I Atlas displays a faint coma and a short tail measuring about 3 arcseconds, confirming active outgassing typical of comets approaching the Sun. Yet these features appear far more subdued than you'd expect for an object of its size and solar proximity. The coma appears compact and dense, rather than the diffuse, fuzzy appearance characteristic of normal comets, which suggests either an unusual composition or maybe even artificial containment of expelled materials. Most puzzling, the object lacks the prominent tail that should develop as it approaches perihelion, with only minimal dust ejection, despite receiving substantial solar heating. Spectroscopic analysis reveals water ice signatures, but the patterns just don't match expected models, with observed signals rising where theoretical predictions indicate they should actually drop. The outgassing appears controlled and limited, almost as if internal systems are regulating material release rather than allowing natural sublimation processes to proceed unchecked. Unlike typical comets that become increasingly active and chaotic as they near the Sun, 3I Atlas maintains remarkably stable behavior and appearance. The reddish coloration resembles outer asteroid belt objects more than pristine interstellar ice, suggesting complex surface processing or perhaps manufactured coating materials. These contradictory characteristics create a hybrid profile that fits neither pure comet nor asteroid classifications, demanding new explanatory frameworks for understanding interstellar visitors. Scientific debate: natural versus artificial. How do scientists reconcile extraordinary evidence with the burden of extraordinary proof? Professor Avi Loeb from Harvard University has publicly suggested that 3I Atlas could represent artificial technology, pointing to its statistically improbable trajectory, perfect timing, and anomalous physical properties as evidence warranting serious consideration of alien origins. Loeb argues that dismissing artificial possibilities without thorough investigation violates scientific methodology, especially when natural explanations fail to account for observed characteristics. However, many mainstream scientists dismiss these claims as irresponsible speculation that damages public trust in astronomical research and diverts attention from legitimate scientific study. Chris Lintott from Oxford University called the alien hypothesis nonsense, emphasizing that extraordinary claims require extraordinary evidence that simply doesn't exist. The debate centers on fundamental questions about scientific methodology. Should researchers explore all possible explanations, even seemingly outlandish ones, or maintain conservative approaches that prioritize conventional interpretations? Critics argue that entertaining alien explanations without definitive proof encourages conspiracy theories and undermines scientific credibility. Supporters counter that science advances by challenging assumptions and investigating anomalies that don't fit established models. This controversy reflects broader tensions within astronomy about how to balance open-minded inquiry with rigorous skepticism when confronting potentially paradigm-shifting discoveries. The scientific community remains divided on whether 3I Atlas deserves conventional analysis or represents something requiring entirely new investigative approaches. Spectral analysis mysteries. What secrets hide within the light signatures that challenge our understanding of interstellar chemistry? Spectroscopic observations using the Gemini S telescope and NASA IRTF reveal that 3I Atlas contains abundant water ice. But the spectral patterns, well, they exhibit puzzling characteristics that don't match theoretical models for natural comet composition. The optical spectrum shows about 10% reddening per 1,000 angstroms, which actually resembles D-type asteroids more than typical ice-rich comets. This suggests either some pretty unusual formation conditions, or maybe even artificial surface treatments. Moving on, the near-infrared analysis flattens to 3% per 1,000 angstroms, indicating large water ice grains. Yet the expected 1.5 micron water band is mysteriously absent, even though there are strong signals at other wavelengths. Scientists have managed to model the spectrum using 70% Tagish Lake meteorite material, combined with 30% water ice. But honestly, this composition seems inconsistent with objects formed in distant stellar systems billions of years ago. The spectral stability across 9 days of observation suggests remarkably uniform surface properties, which is in contrast to typical comets that show variable composition as different regions become exposed to solar heating. Color measurements through various filters confirm persistent reddish characteristics, indicating complex organic materials that could potentially preserve chemical signatures from alien star formation environments. However, the isotopic ratios and elemental abundances appear surprisingly similar to solar system materials, and that really raises questions about whether this truly represents pristine interstellar matter, or, well, something a bit more familiar. These spectroscopic puzzles demand new theoretical frameworks for understanding how interstellar objects preserve and modify their original compositions during million-year journeys through the galaxy. Dark Forest Hypothesis Implications. Could 3I Atlas represent humanity's first encounter with the terrifying cosmic game theory known as the Dark Forest? This hypothesis suggests that intelligent civilizations throughout the universe remain hidden and silent, maintaining strict stealth protocols to avoid detection by potentially hostile species that might eliminate competitors before they become threats. 3. I-Atlas exhibits stealth-like behavior perfectly consistent with reconnaissance missions designed to study planetary systems while minimizing detection risks and exposure to defensive responses. The object's trajectory allows comprehensive solar system surveys while remaining hidden behind the sun during its most vulnerable closest approach, when any artificial systems would be most easily detected. Its deliberate timing ensures minimal observation opportunities during peak activity, following protocols that advanced civilizations might use for cautious exploration of potentially dangerous inhabited systems. The Dark Forest theory predicts that alien visitors would conduct rapid, efficient reconnaissance missions to assess threat levels and resource availability before deciding whether to establish contact, eliminate competition, or simply avoid detection entirely. 3. I-Atlas's behavior matches theoretical predictions for how intelligent species might approach unknown star systems, gather maximum information while maintaining escape routes and avoiding confrontation. The object's ancient age suggests it could represent technology from civilizations that achieved interstellar travel billions of years ago, when the galaxy was younger and potentially more hospitable to life. If this interpretation proves correct, humanity may be experiencing our first contact with alien intelligence, but contact designed to remain undetected until the visitors can assess whether we represent friends, enemies, or irrelevant primitives. Historical context and lessons. The arrival of 3I Atlas provides crucial insights gained from our previous encounters with interstellar wanderers and the opportunities we missed. When Oumuamua was first spotted in 2017, the astronomical community was completely unprepared for studying such an extraordinary phenomenon. Robert Warwick, who made the discovery using the Pan-STARRS 1 telescope in Hawaii, has acknowledged how the object's swift departure left numerous fundamental questions permanently unanswered. The enigmatic acceleration that Oumuamua displayed without any visible cometary activity continues to baffle scientists today, demonstrating the critical importance of immediate and comprehensive observation protocols. 2 years later, Gennady Borisov discovered 2I Borisov from his private observatory in Crimea, giving astronomers a valuable second opportunity that was better managed but still limited by technological constraints. Mark Norris from the University of Central Lancashire has stressed that 3I Atlas represents our most significant chance yet to conduct thorough studies of an interstellar visitor, using cutting-edge instruments and globally coordinated observation campaigns. The enhanced detection systems of modern sky surveys, paired with instantaneous global communication networks, have enabled unprecedented real-time collaboration among observatories worldwide. These hard-learned lessons from previous interstellar encounters have fundamentally transformed how the scientific community approaches these exceptionally rare cosmic events. Future observations and implications. Will the next few months provide humanity with definitive answers about 3I Atlas's true nature, or deepen the mystery forever? Perihelion, on October 30, 2025, offers scientists their best opportunity to conduct comprehensive analysis before the object begins its final departure from our solar system. Multiple telescopes worldwide are coordinating unprecedented observation campaigns using every available technique, from radio astronomy to gravitational wave detection, ensuring no potential evidence escapes analysis. The object will re-emerge from behind the Sun in December 2025, providing a final observation window to confirm or refute artificial origin theories before it disappears into interstellar space forever. Advanced space missions including MAVEN, Mars Reconnaissance Orbiter, and the Jupiter Icy Moons Explorer will attempt close-range observations during planetary encounters, potentially revealing surface details impossible to detect from Earth. Scientists are developing new analytical techniques specifically designed to distinguish between natural and artificial objects, creating frameworks that will guide evaluation of future interstellar visitors. The comprehensive data collection from 3I Atlas could revolutionize understanding of interstellar object populations, formation mechanisms, and the potential prevalence of alien technology in our galactic neighborhood. These observations will either definitively prove 3I Atlas is a natural comet, ending speculation about artificial origins, or provide evidence that fundamentally changes humanity's understanding of our place in the universe. The implications extend far beyond astronomy, potentially affecting planetary defense strategies, international space cooperation, and humanity's long-term preparation for contact with alien intelligence. Future detection systems are being designed to identify similar objects much earlier, providing years rather than months for detailed study and potential interaction. As 3I Atlas continues its enigmatic journey through our solar system, scientists race against time to unlock its secrets before it vanishes forever. Whether this ancient visitor proves to be a natural relic from distant stars or something far more extraordinary, its discovery marks a pivotal moment in humanity's cosmic awareness. The truth about 3I Atlas may reshape our understanding of life, intelligence, and our place in the universe. Stay curious about the cosmos with Simply Science. Like, share, and subscribe for the latest discoveries from the edge of human knowledge.